So rational exponents, the simplifying is going to be very similar to the problems we've been doing with square roots and cube roots and so forth. It's kind of a different notation that we're using, and it's very commonly used, so it's really important to understand it as you go through further math classes. So if we have the nth root of a, like we've been doing, the other way this could be written is a to the 1 over n power. Okay, so start off with a kind of basic example. Let's say we already know how to do square root of 36. That is 6. And we know that this means the second root of 36. So the other way this could be written is 36 to the 1/2 power, which is still 6. Okay, and if you put in your calculator 36 to the 0.5, it's going to tell you it's 6. Okay, so it's kind of just a different way of writing this. So how about let's do one where we just have to rewrite. Let's just rewrite z to the 1/6 using root notation. So that means this would be the 6th root of z. Okay, or how about this one? 3x to the 1/4. Now here, the 3 we have to think about, is the 3 going to be in the 4th root or not? Because it's going to be the 4th root, but just x is to the 1/4 power. So just x is in the root. The 3 would be outside. How about let's do one more that can be simplified. How about the square root of x to the 10th? So using our rational exponent notation, this would be x to the 10th. Okay, that is to the 1/2 power, because this is, right there is the second root, right? Let me maybe rewrite that. Okay, that's the same as the second root of x to the 10th. So now, using the power rule that we know with exponents, we do 10 times 1/2, which is x to the 5th. Okay, so now let's go a step further. So right here we had the nth root of a is a to the 1 over n. Know what is the exponent of a. In this case, this is like a to the 1 power. So we're going to add something here. If we had the nth root of a to the m power, so now we have an exponent inside the root, a to the m power. So this is a to the m over n. Okay, so a to the m over n power is the nth root of a to the m. Now this would be the same thing as the nth root of a, the whole thing to the mth power. Same thing. Now, and this is going to be the one that is used, that's easier to simplify with. So we're going to use that version. Well, you can see why those are the same thing. Doesn't matter if we do the root and then the exponent, or the exponent then the root. Same thing. So let's say I'm asked to simplify 9 to the 3/2 power. Okay, so it's going to be a lot easier to rewrite this as, okay, I'm going to have 9. Now think about where the 3 and the 2 go. The 2 is on the bottom, that's my n, but it's to the half. That is my root. 3 is my exponent. So notice how in this case it's going to be easier to take the square root of 9 first, which is 3, and then do the 3rd power, 27. Okay, so that would have been easier than doing, the other way I would have done this using the first definition would be like this. So I'd have to do 9 to the 3rd power and then do the square root of that. It's going to lead to much bigger numbers. Okay, how about this one? Negative 32 to the 2/5 power. Negative 32 to the 2/5 power. Okay, so now the negative, that's just going to kind of hang out in front because it's not in parentheses, so I'm just going to leave the negative out front. So this is the 5th root of 32 and that is going to get squared. So negative stays out front. Fifth root of 32. What to the fifth power is 32? 2. 2 squared is 4. So my answer would be negative 4. Okay, how about, let's do one more like this. How about 1/4, that in parentheses, 1/4 to the 3/2 power. Okay, so half, the 2's on the bottom, so this is a square root of a quarter, and that's going to be to the 3rd power. Rewrite it. So what is the square root of a quarter? Well, the square root of 1 is 1, the square root of 4 is 2, so that's going to be a half. A half to the 3rd power, so a half times a half times a half. 1 to the 3rd power is 1, 2 to the 3rd power is 8, so 1/8. Okay, now one other rule I'm going to give you. Kind of combines a couple things we've done. A to the negative m over n power. And let me make that negative is, I'm going to put it right in front. That's, the whole thing is negative. A to the negative m over n power. So, using the rule we already know with exponents, when it's a negative exponent, first step, put it in the denominator and make it positive. This is the same as 1 over a to the m over n power. Which, so that, that's kind of the rule. This is the same as the nth root of a to the m power. You could write it like that. All the same thing. So let's do one where we use this. Let's say we are doing 27 to the negative 2/3 power. So first step, write it in the bottom. 27 to the positive 2/3 power. Now rewrite it like we just did the last ones. This is the cube root of 27. And then after I do that, I'm going to square it. So this is 1 over. The cube root of 27 is 3. 3 squared is 9. So 1/9. So basically the only difference when we have a negative exponent, rewrite it in the denominator first.